Good afternoon, everybody. So thank you for coming and attending our talk. So we are Shauki, Thomas, and Pierre. So we are working at Dark Matter. We are going to present you some research we have done between the software lab and the mobile and telecom labs on the security assessment of smart TVs. So basically, nowadays, many companies and the critical like intelligence agencies are using smart TVs as new video projectors. But in the same time, they also introduce new attack vectors against their IT network. So we will show you today a few demos highlighting some security flaws and showing how an attacker will be able to breach the air gap and to enter the network. So the content is as follows. So first we will target the TV itself after explaining what is the attack surface. Then we will move to how to use the TV as a relay in order to attack and to reach and to attack other devices in the LAN. And we will draw some nice conclusions. So as I just said, we are working at Dark Matter. If you don't know Dark Matter, you can just go to the booth or on the website. So let's talk about smart TV and understand why they are not really smart devices. So what is a smart TV first? A smart TV is basically a very old basic TV where we decided to put inside new network interfaces, and we added new, let's say, smart operating systems with web technologies, applications like smartphones. We also increased the entertainment by adding the HBB-TV support to TVs, and a lot of wireless interfaces. So the one we commonly see are IR, DVB-T, DVB-S sometimes for satellite broadcasting, Bluetooth and Wi-Fi. But we also have seen that many televisions propose the interface in order to connect a USB dongle for 3G and 4G connectivity. And seeing all those new technologies and new services enclosed in a single device, the first question as security researchers we have been asking ourselves is, what could go wrong? And today we will show you what has been done well and what are the real security issues. So many papers have already been published on this topic related to privacy issues, showing that analytics are sent to third parties periodically, and then the manufacturer is able to analyze the way you use your smart TV. They also have shown that some models enclose microphones, and by that you are able to control and command your smart TV. Manufacturers and editors decide also to grab all those voice commands you are sending in order to process them and get more information about your emotions when you look at TV and how you use your TV. Concerning the security issues, as you may have already seen during the Vault 7 leak, intelligence agencies have a lot of interest in smart TVs. And a full exploit was described in the Vault 7 documents, where it was shown that the CIA has a full exploit running when they connect the USB key to Samsung smart TVs. So many papers, recent one is from Fortinet, where they have found critical vulnerabilities in Sony smart TVs, multiple attack vectors from the network, Wi-Fi, from DVB-T, and reading all those papers, we have seen that basically the security level is very similar to computer security 20 years ago. So the main question here is, why a new talk on this topic? So most studies highlight findings, nice vulnerabilities and nice demos, but few are covering testbed. How security researchers have tested smart TVs to uncover those security flaws. So when we decided to work on smart TVs, we wanted to make that as simple as possible, using only open source tools, and only connecting those tools in order to come up with a nice smart TV testbed. So we will release a blog post soon on how we build the platform, which tool we have used, how we connect them. But briefly, here is the setup. So we have one USRP to transmit the DVB-T signal, which is here. We have one target, which is this one. We just booked it yesterday evening for the demo. The Giro DVB-T, which is available on GitHub in order to transmit DVB-T signals, and the HBB-TV test suite, which is a very good starting point, because this is basically a framework to test the implementation of smart TV standards. So we grab all those tools and we come up with this platform. So here is the laptop. We will send the signal to the smart TV. The signal will reach the receiver of the tuner enclosed in the smart TV. We will see the video records that was also available on the internet. And then the TV will be connected to a remote server that the attacker is controlling. And the attacker will serve a lot of payloads to the TV, the payload that we have implemented, in order to see if we find nice vulnerabilities and maybe nice 0 days. So currently we have 3 0 days released and reported to Sony, and they ask us to wait 6 months to release the description. And then we will receive a nice t-shirt. This is super cool. So what's next? In this talk, we will show you how we targeted the smart TV from several perspectives. So basically attacking daemons on the LAN or VLAN, crypto miners, some exploits, malicious applications, ransomware, all kind of things that we may use against computers. We decided to use them against smart TVs. We will also show you how we use the smart TV as a relay in order to attack some smart devices. You know that today we have a lot of devices connected to the home network. So let's see what we can do against the IP camera here. And I think now Thomas will present you what we did against the smart TV itself.
So I will talk about the attack surfaces for the smart TV. So which means I will talk about how can we find vulnerabilities and also exploit them. So we divided the attack surfaces into 3 categories. So the first one is the applications. So as this TV is supposed to be smart, so for sure we will find application to play with. And API and libraries, because we can be sure we can find fancy API and custom libraries, which has not been tested before. And then the network. So this is a TV, so there is a video stream with metadata, and maybe there is a way to find vulnerabilities inside this. So let's start with the first one. So during our first investigation of the TV, we noticed that a browser is used with the TV, and this is an outdated Opera version, which dates from 2015. And you can see on the screenshot, so on the top left of the screenshot, there is a user agent, which is Opera. But at the beginning, we were surprised because the bigger agent showed us that the browser used was Chrome. So we don't know if this is a kind of a user agent spoofing or whatever. And also, as this TV is supposed to be smart, for sure we can find a way to perform a debugging into the TV. And we noticed that ADB is present on this TV. And because this is based on Android. So at this point, at the application level, we can target some attack related to browser and to some API, actually. So let's talk about the API. So, yeah. All right. Okay. So we found a lot of outdated libraries. library is used for parsing, like JPEG, etc., and also for video format, like MP4. And we also noticed a custom version of JavaScript is used. So this is all standard surfaces you can use to find vulnerabilities. But there is a more specific one, like EPG, Electronic Program Guide. This is in fact the TV guide you see on the TV. And it is just broadcasting, and the TV read this information. So this means there is a parser somewhere. And the last one, and the most interesting one, which is the XML AIT. AIT means application, I forgot. Okay, something. But it is used to install remotely an application without any authentication or without any user interaction. So we have all kind of vulnerability, like all the memory corruption bug, the all configuration issue, etc. But now we have something like the specification. So you read the specification and you have the remote code execution. So this is also a nice target to just execute code on the target TV. And the last one, the network. So we can use WebSocket and XML HTTP request. So this means we can perform other stuff, like using the TV to perform scanning on the daemon running on the TV, or scanning of the network where the TV is plugged in. So this is a way, in fact, to perform like a pivoting into the network from the TV. And we have also the metadata on the video stream. And so we have what we call the service description table. And this is just a stream we can use for finding vulnerabilities into the video stream. So we can make a demo about what we call fake news. So in fact, we can send a stream, and we can just modify the current mainstream to display our own messages. And this is in fact an application which is running directly on the TV.
So basically we have all the payloads here. You can go through and just execute them. So for example, what said Thomas, it's the Barre overlay. So basically, if we want, we can just send some fake messages on the TV.
Yes. And in fact, we noticed something on the TV. So you can change channel, but when you do that, normally the application should be killed. And actually, I think it is not killed. So this means we have a persistence on the application into the TV. Okay, so now we are going to talk about the pivoting. So in fact, we can, as we can execute any application on the TV, we can use it to perform, for example, crypto mining, which is not effective because this is a TV. So, but you have also the port scanner. We can easily perform using WebSocket, or you can use the TV to target other devices. So if you have, for example, any exploit on any devices, let's say a router, so you can just use the TV to send this payload to the router. And in fact, there is other thing we can do with that, like for example, using all the voice-enabled assistant devices from the TV, or also imagine you want to do some red team exercise, and so you target the Wi-Fi by trying to perform a man in the middle on the 82.1x protocol. But in fact, you can just target the smart TV, and you can use the smart TV to perform a scan into the network and to send payload. So you can do that without any, it is not required to have any authentication or user interaction. It will work for sure, just by using USRP and targeting the smart TV. So you can see into the screenshot. So we have some payload which we are running. So there is one who we're scanning the network, all the IP ranges, and one which is scanning the daemon running on the TV. So now Pierre will talk about how we can expand this attack surface to make much more interesting exploitation.
Thank you. So the goal was also to expand the attack surface. Basically, we found 0 days inside TV, but we realized also that the TV are connected to home networks. So we are also doing some security researches against other devices, and we wanted to use television remotely, even on a complete isolated network, and we wanted to abuse them in order to attack other devices. So the goal was to target local area network, basically router, NAS, cameras, IP phone, network appliance, if it's connected, and if you have some TCP ports open on the device with vulnerabilities, then the goal was to exploit them. Also, everything about wireless local area network, like access point, because the security of routers, access points are very bad, and they are very interesting to study. Also, a very interesting point is that we can execute code, mainly JavaScript. We also have access to WebSocket. In some recent TV, we have access to WebAssembly, so it allows us to write exploit, very effective exploit in order to target some devices. So the master plan at first was like to analyze all the network in order to find a potential target. So you can just scan the network using JavaScript or WebSocket. Then you do a simple service enumeration. From that, you will try to find vulnerable services. Then you write your own exploit. So it can be 0 days or using public CVs. And finally, you just abuse remote code execution against daemon. So you can target UPnP, HTTPD, a lot of custom daemons when it's TCP related, because on WebSocket you can only use TCP, so no UDP. So now reality. It didn't work well at first, so we had to work a lot. The first proof of concept was simply DOS using television. So in fact, the parsing of JavaScript is very bad. So you can craft an HBB TV application. It will work well on a specific model, and then another application, another television will crash. So we were like, oh, this is very strange. Also, the first proof of concept we wrote was DDoS. Basically, using HBB TV, you can send a crafted HTML application using JavaScript, containing JavaScript, sorry, and we wanted to start DDoS against a remote service, remote website, for example, and it works well. So basically, we just send the HBB TV signal, and the TV will start to flood a remote server. So also, as Thomas explained, browser security is very bad. You have Chrome inside. You also have Opera. For example, the HBB TV browser is based on Opera, but when you read the user agent, it says Chrome. So at first we are like, well, super, we have Chrome. And in fact, no, we have a completely outdated Opera. So we did a lot of debugging using TCP dump, a lot of ADB. Why ADB? Because a lot of smart TVs now are running Android systems. So you just activate ADB, and then you have access to a lot of logs. And also, we had some luck, because some stuff didn't work, and then it works completely by magic. So we are very happy. The result, basically, we have a complete test bed, so you can scan internal networks. You can also scan external networks using JavaScript and WebSocket. We are using the television in order to exploit 0 days against devices. For example, camera. So this camera model I found 0 days last year. So just in the test bed, 0 day camera relay attack. and it works. So basically how it works, we are sending the signal, then the television is sending a specific request to the camera abusing a specific vulnerabilities, which allows us to get remote code execution. So normally it's completely silent. Here you are seeing the output because we want to show that we have the control of the camera. But the fact is you can use the camera to create a new hotspot or to connect to another wireless network, which means that a complete isolated network is now completely open. You can connect to a target network and then you have access to this network. Also, we targeted some router. We found vulnerabilities in different routers, and we wrote all the exploits using JavaScript. So basically, just by sending HBB streams, we can target routers remotely. So it was a huge success at the end, a lot of debug because JavaScript implementation, depending on the vendors, on the camera, on the television models are completely different. The fact is, it's very useful to use television as a relay. WebSocket and JavaScript are very, very powerful. But the fact is, we wanted to do more. So we started to work on an ADB implementation in JavaScript because it's running Android. And if you can have a ADB client in JavaScript, you can do a lot of things. Also, we are working on a more effective scanning solution, and we are currently implementing a lot of CVs, so we are rewriting them in JavaScript. So at the end, I think that we can say that television are complete toolkit for attackers. If you want to enter into a network, you can use smart TVs because you don't have logs. It's very easy to enter inside, and it's very hard from a defensive point of view to have good defensive security. If you want to enter, just use TV and you are in. So conclusion, Shoki?
So we have seen that the security of the television is really low today. Since 2011, a lot of vulnerabilities in 2014, and still today we find a lot of security flaws. So we have the first funny conclusion, basically, let's use smart TVs as CRT monitors. Deactivate the HBB TV option. Again, it's a software deactivation. If you trust it, it's good. If not, then it's not enough. Wi-Fi, Bluetooth, if you can disable them, we have seen that many televisions don't give the possibility to users to deactivate them. So it means that even if you disconnect them, you will not be able to remove the interface. No HBB TV again, no RJ45. If you don't need that, just remove them, especially in critical networks. But seriously, if you have to use those devices in your infrastructure, make sure to have done a proper security assessment of the device. Test them to be sure that they will not be the weakest point in your network. And do a proper risk evaluation and check the needs and what you can gain from using them and what you may lose by connecting them. So thank you very much for your attention. We are open for questions if you have any.
Thank you. Any questions in the room? Okay, the first one.
Great presentation, guys. Just circling back to the broadcast where it says your message is here. So, you know, there are like basically POCs that people did on YouTube and stuff saying that they can manipulate live air messages. But help me understand, or just to clarify, you're manipulating the message on air or from the TV?
So there are two things. Any payload that we have tested today, they have been sent to the TV from the server behind.
Okay.
Just because for efficiency. So we just wanted to do things fast and to find things as soon as possible. But each payload that we have presented and the ones that we have shown on the screen can be enclosed directly in the RF signal. So what the attacker will do, he will have two RF devices. He will grab the signal from one side. He will repack the signal with the malicious application and replay it.
So man in the middle, basically.
Yes, you can do it live. Like, yes, you will have some latency, but it's 1 minute to reprocess the signal.
And another question. So a lot of home, I have a smart TV and I also have a smart DVD player and a smart home theater thingy, whatever you call it.
Everything is smart.
Exactly, which is a real dumb idea. But did you guys come across when, okay, for example, let's just take the Sony TV, and, do you find a lot of commonality of the vulnerabilities on, like, say, for example, the Sony DVD player? So that's another attack surface that you were able to...
I mean, we didn't test that, but if we, let's say, just a question of what kind of devices we have in hand. So we work on the Sony TV just because we had one.
Yeah.
And we booked the same one because we wanted to make the demos today. But yeah, if tomorrow we have to work on Sony players, PS4, other devices, we need to find vulnerabilities in them and then weaponize them with the smart TV.
Okay, thank you.
Any more questions? We are a bit out of time, but
Later, that's fine. I'll do the offline. Just one question. So software, like you told, like Opera browser, they are using from 2015. So is there any option that we can manually push for updating of that browser?
No, because the firmware are so, well, it depends what is your goal. Is it to protect and update all devices, or is it only to protect your device? These are two things. Normally, Sony should take the last version of each software, take them and push them on each TV. It's not the case today. If you want to do it, you need to bypass the firmware signature. So you need to do some work at the low level to be able to do that. We didn't work on that because for us, the goal was to say, guys, you are using smart TVs. We are seeing them everywhere in all offices. Let's just step back and think about what we are doing when we are using them. That was the goal of our research.
okay, thank you guys. We have to clear the stage for the next speakers because we're way ahead of time.
Thank you.
Way over time. Thank you very much. It was a great presentation.